Okay, we're going to finish looking at a couple of more transformations for our graphs. So far, we've covered shifting things vertically up and down by adding or subtracting on the outside, shifting my graph horizontally by adding or subtracting on the inside, and then vertical and horizontal stretches and compressions by multiplying either on the outside or the inside of my function. There's two more we want to look at. Suppose we use our basic square graph again, only now I want to look at f of x equals negative x squared. Keep in mind, that negative is on the outside. You're going to square first and then make it negative. So, what does our graph look like? If you plug in 0, you get 0 squared, which is 0, and then make it negative, but negative 0 is still 0. If you plug in 1, you get 1 squared, which is 1, and then make it negative, which is negative 1. So at 1, we get negative 1. If you plug in 2, you get 2 squared, which is 4, and then make it negative, negative 4. And it should be obvious it's going to do this. Since we know these are parabolas, we can guess what the other half will look like. But just to do it once, if you plug in negative 1, you get negative 1 squared, which is 1, and then make it negative, which is negative 1 again. So at negative 1, you get negative 1. And then we can see that, yeah, that's just a parabola turned upside down. So as far as it goes, multiplying on the outside of your function by a negative reflects you across the x-axis. The trick is, as far as the terminology goes, we know when we said last time, if you do something to the outside of the function, it affects it vertically. If you do something to the inside, it affects it horizontally. That negative is on the outside, which means it affects it vertically. And essentially the idea is we're taking it and we're rotating it vertically this way, which results in it revolving around the x-axis. So just don't get confused because it's the x-axis and think it's a horizontal flip. It's not. Technically speaking, it's a vertical one. But essentially, if you multiply by a negative on the outside, it will affect your graph across the x-axis. So, suppose we look at one more transformation. And just for fun, we'll use a different function this time. We'll use f of x equals x cubed. So, we know the graph of x cubed is the elongated s. Now, find the graph of f of x equals negative x cubed. If we plug in 0, we get negative 0, which is 0, and then cube it, which is still 0. If we plug in 1, keep in mind the negative in here is on the inside. So if we plug in 1, we get negative 1 cubed. Negative 1 cubed is negative 1. So at positive 1, we get negative 1. If you plug in 2, when you plug in 2, you get negative 2 cubed. Negative 2 cubed is negative 8. So at 2, we get negative 8. And we can see my graph will look like that. If we look on the other side of the graph, if we plug in negative 1, we'll get negative 1 cubed. Negative, negative 1, two negatives cancel and that becomes positive, and then we get 1 cubed, which is 1. So at negative 1, we get 1. And it should be obvious what's happening, but just so it's clear, plug in negative 2. We'll get negative 2 cubed. Again, these two negatives cancel, and you get negative 2 is positive 2 cubed, which is positive 8. So at negative 2, we get positive 8. And now we can see it's just my cubic again. Essentially what happened? Well, before, when we had a negative on the outside, it flipped across the x-axis this way. Now, when there's a negative on the inside, well, we just took this graph and flipped it this way. Again, horizontally. So negative multiplying by a negative on the outside reflects you across the x-axis. Multiplying by a negative on the inside will reflect you across the y-axis. That's all the transformations we need, but I want to do at least one graph out with several different transformations just so we can kind of see how this works. So suppose we have f of x equals negative 2 times x plus 1 squared minus 3. We want to graph that with all the transformations. I know you can just plug it into your calculator and get the graph. So when you guys are turning in your homework, and several of you have already asked about this, email your homework to me, but I want you to write out, I know you can't use Microsoft Word, write out on separate paper the graphs of these functions like I'm going to do right now, and then just take a picture of it and email me the picture because I want to see all the graphs you do. Well, let's see. The way this works is find a basic function to start with. In this case, clearly it's x squared. So we'll start with an x squared graph. F of x equals x squared. Basic parabola. And now using that graph, build that graph right there, step by step, transformation by transformation. So let's see. We don't actually have x squared. We have x plus 1 squared. Well, what does x plus 1 squared do? Adding on the inside shifts me horizontally, plus 1 goes to the left. So my parabola will move 1 to the left. But I don't actually have x plus 1 squared. I have 2 times x plus 1 squared. I'm aware that technically that's a negative 2, but it's actually 2 different transformations. One for the 2 and one for the negative. We want to do them separate. So, if I multiply by 2 on the outside of my function, well, that stretches it vertically, makes it thinner. So the graph that looked like this now gets thinner. But I don't actually have that graph. I have negative 2 times x plus 1 squared. What does multiplying by a negative do? When you multiply by a negative on the outside of your function, it flips it across the x-axis. So this graph will flip across the x-axis and look like that. But we're still not done, because we don't actually have this. We have negative 2 times x plus 1 squared minus 3. Well, what does that do? Subtracting, adding on the outside of a function shifts it vertically. So minus 3 will shift me down 3. So I was here, now go down 3. And just kind of keep track of the vertex in your head. We shifted it 1 to the left over there. Now we're going to go down 3, which means my vertex ends up down here. X is negative 1 to the left. Y is negative 3 down. And then it goes down. And there we go. There's my graph using all my transformations. When you guys turn in your homework, this is what I want. On separate paper, list out each of the graphs like this. That covers all the transformations and how to find them. If you have any other questions, feel free to email me and I'll do more examples of this. But otherwise, we should be good.